Hello, my friend. My name is Anton from Calendar.com, and today we are going to introduce you the new tool that we have created recently, which is called the Hawk. The Hawk stands for the highly efficient automatic weapon key. You might think, why are we speaking about the weapons when we speak about the network automation? Right? In the reality, each and every network is sort of workplace, and you need to have the corresponding tools for you to help you with. Now, why we have created the tool and what does it do? The Hawk allows you to visualize your real life state of the network where it started from the data center fabric so that you understand which links are up, which links are down, how is routing sessions looking like in your network, which would allow you, based on the real data grabbed from your devices, to perform not only visualization, but also what-if analysis. Say you are planning some maintenance work and thinking which devices simultaneously could you switch off, which should be still up in order to make sure that despite you are, let's say, planning to update software on some devices or do some other significant change which require you to take the device out so that your traffic still continues being flowed through the network. This was the purpose why we have created this tool. And start with one vendor, for now just Cumulus, so that you can grab this info and make real-time analysis. Instead of just speaking how cool the tool is or how it's not cool, let me just show you how it is working. So to start with, let me quickly show you the topology we are going to use during this simulation. This topology we are using in our near automation training, which is, by the way, start just in a few days. So you still have possibility to join and get the nice knowledge about automating multi-vendor network with Cumulus, Arista, Nokia, and Cisco together with various protocols, SSH, NetConf, JNMI, RESTConf, and whatsoever. But going back to the Hawk. So we'll take this topology, which is running currently in our lab, and you will see how we could visualize, how we could check the first of all, whether this topology is real or not. So we have this topology, first of all, documented in the Netbox, and we are using the Netbox as an inventory for the Hawk tool, as Netbox is very popular across the globe in the various data centers. So jumping first in the Netbox to our site, the test one which we are using, you might see that we have a bunch of the devices. As I said, for now, we have focused on the devices which is having the Cumulus in the platform, but we are looking to spread their coverage from the Hawk to other vendors as well. So mapping this to the topology, you might see that we have two border leaves, 4 spines, 2 of which are based on the Cumulus, and 2 Cumulus spines. So far in the topology that we'll be rendering with the Hawk, we will have only Cumulus-based switches. However, if you have a full data center, which is running on the Cumulus Linux-based switches, such as, for instance, guys from the AWS are running, you might have possibility to visualize and make the perform analysis in their whole your estate. So the reality from the Netbox, we just need to grab the information about the device's host names and the IP addresses. Now, we know that in certain cases, various companies are using the Netbox in the various things, and some companies are using IP address, primary IP address, as an entity of the device as management IP. Others are using at the loopback. So what we have created in the Hawk that if you don't provide the IP address for the device, but within the device you have the interface which is called ETH0, you still be able to pick up that IP address and connect to the device based on this IP address. So what Hawk is doing, you provide it connectivity towards the Netbox. I'll show you it in a minute. Your token and the name of the data center you would like to collect the info and make the real-time analysis. And then the Hawk is doing the rest, is grabbing the info from the Netbox, is building the internal inventory based on that. Then it's connected to the devices to collect the information about the IP addresses, interfaces, and depending on the topology you ask, say BGP, IPv4, IPv6, it's grabbing this info and building the network graph. And then based on the graph theory, it makes the analysis, validating the connectivity between the endpoints and the visualization. So now it's time to really jump to the Hawk. So within the GitHub, we have a repository to our webpage, toolkit.com. So we have our company repository, and you could find the whole repository in there. All you need to do is just clone it. So copy this link, download it to your host on your laptop or your server, and install the necessary dependencies. So we have a file requirements which contain the information about the tools we are using. In the many cases, as you see, we are relying on the asynchronous libraries to speed up both the interaction with the Netbox in order to perform all the queries in the asynchronous manner, and async SSH to help to speed up the process of collecting the information from the devices in the asynchronous manner. So we have this already downloaded. So I said, just make git clone, you go to your host, and you are having the folder containing a lot of various information. So the README contains a general description of what the tool is doing. So far, we have only first script within the tool of the whole framework, which is called Topology Analyzer. This is a tool what we'll be looking into. So we have this installed within the virtual environment. If you'd like to learn more about the Python and virtual environment, join our training network automation, which is available as a self-paced training, or you would be able to start the new session beginning of the summer. And really, once you have installed all the necessary requirements out that file, you can start working with this. So the tool contains the necessary help. So if you run the topology analyzer with the key-h, it will show for you the bunch of the parameters that you could provide. In this video, I will show you only the first functionality, which would allow you to visualize the data. In a separate video, we will cover the what-if analysis. So the inventory, so the repository contains a file called config.yaml. Contains all the necessary data which allows you to interact with the Netbox. So it's created in a simple YAML format. So if you, it's probably one of the most simple format that just exists on the market. From the data encoding perspective, from its inventory type, you need to type that this is a Netbox. This file is coming as part of the repository, so you really need only modify only the URL, token, and site. So site must be following the slugs that you have in the Netbox. So if you go back to my topology and show you my site, as you see, it's called NRN, which stands for non-linear set. So we are using the non-linear topology, and the slug would be NRN in the small register. That's why we're having the small registers in our inventory, just in here. So token from the Netbox, you're taking it from your inventory, from your profile. So you go to the profile and then API tokens, and then here you have the key. So you're grabbing this key and you could add it to that file. If you are not happy about putting your tokens in the configuration file, which we totally understand, we can provide this token as a part of the inventory. And in fact, this is probably a recommended way of doing things. So how to be doing it? The same is related to the credentials. You could either provide the credentials as part of the inventory files, or as inventory, or as virtual environment. So just type the keyword export. For the Netbox token, it would be NB token, and then providing the token in here. So to provide the credentials, you also need to provide credentials to connect to the devices. Again, we're using the same environment. So Hawk user, in our case, this is Cumulus. And I need to provide also the Hawk pass, which is a password I'm using to connect to the devices. So let me find my password. As usual, it is relatively complicated, but as we're using this for the lab, I will show you just in a second. So, okay, I'm almost here. And I'm done with that. So here is my password. I put in the quotes because it contains some special short. So we have now all the credentials set, and we could start working with the tool. So the very first thing what you are really do, just type the name of the tool, then the key per the information shared earlier -d, which would mean the data center, and provide the name data center. So if you don't provide, I mean, you could provide it as a part of the inventory, or you could provide it as a part of the arguments in case you would like to modify the data center, which is not like default one. So it's, again, these two keys are really optional, but we are having in there to have some sort of the default variables, which would be used in case you don't provide anything extra. So providing the name of the data center, all the operations are in there defaulted. So if you don't provide anything else, and you could just run it like here, it will create for you the necessary information. So you see we have the folder output. Within the folder output, it's create the folder subfolder, which is followed by the time when you have created. So you see that the exact timestamp and the file. If you open this file, it's a real topology that we have right now in the network. So you see we have a 6 devices. So we are building by default the BGP topology. So you see the name of the devices, how they are called on their devices in their real configuration. I mean, their IS number, their role, their plane, which is a plane is applicable for their spines. So where this info is coming from about the roles or the spines. Within our configuration file that I already showed you, we have a part called mapping. So we have our internal roles, leaf, spine, border, aggregate, DCI. Now, we know that each and every company might have its own naming convention. And that's why the names that you see here within the leaf, within the list associated with it in every role, this is a name that we are having within the Netbox. So say if I go now to the Netbox and show you my devices, so you see the role border, leaf, and spine. This is the name of the roles that you see in this mapping. So if your company is called not the leaf, but let's say top of rack or TOR or any other acronym, you could just put here the real name, how you have it in your Netbox, and then this role would be mapped to our internal structure, standard data center, leaf, spine, border, aggregate, and DCI gateways. And this info then would be correspondingly analyzed internally within the our graph. And that all together allows us to build this visualization that we are just showing you. Let me jump probably to one of these devices. So if I go to, oh, okay, so this is my password, perfect. So if I go here to, let's say, one of them, so you see this is leaf 11 and RN. The topology show that leaf 11 is connected to two spines, spine 1 and spine 2. If I run here and I show BGP summary, you would see that it's exactly how my sessions are done. So some of them is still having the old name, but from the perspective of the device, it is having the proper name because we are making the mapping based on the IP addresses. So if I go to that device itself, let me think, I think probably it's one of the devices. Yeah, so you see this is a spine and then one. And let me jump to another one, spine here 6. Okay, so now let me change here, or let me basically check here my host name. So let me add here the proper name, net add host name. And this would be another nice use case, spine 2, find 2-nrn. So you see, I'll be changing the host name. In order for this change to be applied, to be working, I need to reboot the device. So I will do it now. So device now is not reachable, and I'm repulling the info from my network. So it will collect the real-time info from the device where it could connect and collect this information. So it's taking some time because it needs to make a timeout. And if I show you now this topology, what I'm having, open, I have a real in the Finder. Now you see topology is different. And this stage Zeus device is not available. And that's why it shows, okay, sorry, but we have only one spine and only one plane. So basically, obviously, if this device would went down, then we'll have a problem with the data center. So let me see if device is up now. So it is back. And now I would rerun the whole collection again. And we would now have now you see it's worked quicker because it have connectivity now to the corresponding data. And now again, it shows for us the proper topology, the proper graphs. Okay, so visualization works fine, right? So, but as said, it shows the real-time data. So you saw when the device was down, it was not pulled because we were not able to connect to it. And therefore, we're not able to collect the real data about this. So what if the device is up, but the session is down? So let me really do that in this way. I would add here net. Let me think how it would be. BGP neighbor, probably that would be my neighbor. I think it will be Dell. So that basically should bring the network down. Let's try that. Let's probably may do it differently. So okay, now shooting this down should bring the BGP session down. So session is, let me run it again. So running our visualization, info is collected from the devices, and we can open this and see, as you see now, we have this session is red. So basically the planes are having different colors, blue, green, and some others for big data centers. But if the session is really down, it is shown with red, and you see the real state of the session. It is active. Basically, the session is in here visualized from the perspective of the spine. We make a shutdown from the perspective of the leaf, but from the spine, it is not shut down, it is active. So that allows you to visualize small data centers, big data centers. Our scale tests show that the visualization of the data center with roughly 100 switches is taking probably about 10 seconds, slightly more. Just predominantly the time is getting not to do the visualization and analysis to build the mass model, but rather than to grab the proper information from their devices. Because if you still, even if we are doing the asynchronous way, we need to collect a lot of data and we need to put that together. So this is the first functionality of the hub, which is called real-time analysis. And the separate video, we will show you how we can make a what-if analysis, which makes the hub a special tool for your and the helper for you to plan your maintenance activity or just to understand what would happen if something would happen in your data center based on the live data. Thank you very much and see you in the next video. Take care and goodbye.